Alright, so let's continue our journey on calculus, that's function of function. But today we'll be looking at exponential function. Right, so let's jump into it. Look at this is our e raised to the power of x. This one, we're looking at what it means. Right, in our term when we are doing, I have a whole course on binomial theory. Right, how we expand using their summation formula. Now in summation, what it means, what all of this means, let's just get straight to it. All of this means is that arrow is increasing from 0 to infinity. Right, these are arrows increasing from 0 to infinity. Summation of what it is, it's increasing, and it is increasing based on this pattern. This is the formula for how we form the summation of what it is. Right, so e raised to the power of x has this term as x raised to the power of arrow over arrow factorial. And what this means is that if we are trying to get the summation of e raised to the power of x, it is going to be x raised to the power of what? Arrow is starting from 0 raised to the power 0 over arrow factorial. Remember, arrow is starting from 0 factorial. Right, that is wherever we see arrow, because we are starting from 0 to infinity. Let's just take our infinity, let's just end in 6. Let's assume we are ending in 6. Right, so that I can easily explain. So we are counting from 0 down to 6, right, following this order. That's what it means. Summation plus, we are summing them, plus, if we've done 0, next will be 1, because we'll do that till we get to 6. It's actually was infinity, but we're doing it till we get to 6. So starting from 0, increasing, we're going to have what? Plus x raised to the power of what? Arrow, which is from 0 to 1, right? 1 over what? 1 factorial, right? And then we sum again, plus x raised to the power of, we have done for 0, for 1, increasing to 2 over what? Over 2 factorial, right? Plus what? Plus x raised to the power of 3 over 3 factorial. That's why we are increasing, because it's following this order. This is the order which is following. Plus what? Plus x raised to the power of 4 over 4 factorial plus x raised to the power of 5 over 5. Okay, let's stop here. Let's just say we're using 5, not 6. 5 factorials, right? So this is what it literally is. If we expand that, we will know that e raised to the power of x, our exponential function, is simply as x raised to the power of 0 is what? Is 1, right? 1, and 0 factorial is 1. Right, you know what factorials are now, right? If we have, like, they ask us to do 4 factorial, we know that 4 factorial is simply, we are multiplying them, we are in the decreasing order. So it is 4 times 3 times 2 times 1, right? That's 24. That's all about that for factorial, but we're not treating factorial. I'm just trying to explain using that. Right, so I haven't done that. X raised to the power 0 is 1, 0 factorial is 1, plus what? Plus x raised to the power of 1 over 1, plus what? X raised to the power of 2 over 2 factorial, which is 2 times 1 gives us 2, plus what? X raised to the power of 3 over what? 3 times 2, that's 3 factorial, so it becomes 3 times 2, plus what? X raised to the power of 4 over 4 times 3 times 2. I'm sure you understand what we're doing. Plus what? Plus x raised to the power of 5 over what? 5 times 4 times 3 times 2 times 1 times 1. We know what we want to do. So if we our normal expansion or the exponential function is simply 1 plus what? X raised to the power 1 is seen as x plus what? X squared over 2 plus what? X raised to the power 3 over 6 plus what? X raised to the power 4 over what? Over 24, right? Plus what? X raised to the power 5 over 120, right? And then plus so on and so forth, right? We're doing to infinity, so on and so forth. Therefore, just know that therefore our exponential function, which is e raised to the power of x, has this value 1 plus x plus whatever it is down to infinity. This is all about that exponential function. Starting from here, this is what it actually means. So I'm trying to show you the value of exponential function. The exponential function e raised to the power of x is this, but this is not what we are driving at. There's something I want us to understand. Right, so what we are trying to establish is not this actually. I'm just trying to show you the value of what this exponential function is. Anywhere you see an exponential function, this is what it actually is. This is the value for an exponential function. We are trying to form our derivative of this exponential function. What becomes the derivative of the exponential function? That is to say, if we have y raised to the power of e raised to the power x, what becomes dy over dx of this? That's what we are driving at. So just pay attention. I'll clear the board and then I'll show you how this is being proved. See you in the next video, guys. Alright guys, so in the former video, we tried to establish the fact that e raised to the power of x has this value by using the summation function to expand it, right? That's whenever you see e raised to the power x, the value of e raised to the power x is actually this, right? So what if we have, since we are talking about function of function and we're still on calculus, right? What if we have that y is equal to, if y is equal to e raised to the power of x as our exponential function, the function of that, let's find what we dy over dx is. We all know, for those that are advanced students in calculus, we know that dy over dx will give us e raised to the power of x. Is the same thing, but how? Let's try and see how this is true. If this is true, let's get how this is true. How do we know this is true? Now let's use their value as case study. If y is equal to e raised to the power x, which is actually 1, right? Yes, 1 plus x plus what? X squared over 2 plus what? X cubed over what? Over 6 plus what? X raised to the power 4 over 24 plus what? X raised to the power 5 over 120 plus so on and so forth. If that is that, therefore our dy over dx becomes what? Look at now. Instead of using this to get the answer, I know it's quite impossible. Let's use the value of this to try it out. Right, so let's go. Let's try with the value. If y is equal to all of this, dy over ds with this becomes what? If we differentiate the constant variable here, it becomes 0, right? It's 0. This constant variable is 0. Plus, if we differentiate x, what do we get? 1. Yes, if we differentiate x, that is, if y is equal to x, we know that dy over dx, using the general formula I've been teaching you, x raised to the power of 1, we have 1x, 1 minus 1, right? So it becomes 1x, same thing as x, 1 minus 1 is 0. Anything raised to the power of 0 is 1, 1 minus 1 is 0, anything raised to the power of 0 is 1. So therefore, you know that dy over dx here is simply 1, right? If we differentiate an x, we'll get 1, so this is 1, right? Plus, let's differentiate this. If we differentiate this, what do we have? We know that 2 will come here, which is 2x, and then 2 minus 1. 2 minus 1 from here becomes what? 1 over 2. Right? So let's go. Then what do we have next? Plus what? If we differentiate this guy, we'll have 3x raised to the power 3 minus 1, which is what? 2 over 6. Let's continue. If we differentiate that, we're going to have what? For this, we're going to have 4x raised to the power of what? Plus 4 will come here. Just as 3 came here, 4 will come here, 4 will multiply whatever is here, and then 4 minus 1, which is 3 over what? Over 24. Plus what? We differentiate this, we're going to have 5x raised to the power 4 over 120, right? And so on and so forth. So on and so forth. Now work with me, guys. Look at now. 0 is gone, we just have 1, right? This is the differential, right? 2 here is 1, 2 here is 1, we're left with this, right? And then 3 here is 1, 3 here is what? Is 2. 4 here is 1, and if we come here, what do we have? 4 here will give us 6. Right? Yes, if we differentiate for this, 5 here is 1, 5 into 120 will give us 24, and so on and so forth. So if we try and arrange them, after cancelling it, you try and arrange them, you will discover that dy over dx, our dy over dx will give us what? To give us 1, because this is 0 is gone. We'll start with 1 plus what? Check, what do we have next? X, because this and this are gone, all of this here are gone. We have just x here. Plus what? You see we have x squared over what? 2. X squared over 2. Plus what? If you check here, we have what? What we did there, we have x raised to the power 3 over 6. After cancelling that, x raised to the power 3 over 6. Have x raised to the power 3 over 6. Plus what? Plus what? Check now. Yeah, we have x raised to the power 4 over what? 24 after dividing. So we have plus x raised to the power 4 over 24. That means, let's spread it up. That means our dy over dx will give us what? To give us 1 plus what? X plus what? X squared over 2 plus what? X cubed over 6 plus x raised to the power 4 over 24 plus so on and so forth. If you check carefully, you will discover that even after differentiating, we are still getting the same value as this. If you watch there, you will see that our dy over dx for this is 1x squared over 2 plus what? X raised to the power 3 over 6 plus x raised to the power 4 over 24 plus so on and so forth. So we can establish the fact that using their value signature, if we do it, if we know that if we do our y equal to e raised to the power x using their value, and we differentiate further dy over dx of this, if we're using their value, we are still going to get e raised to the power x. So wherever you are, understand that the differential or the differentiation of exponential function will still give us the same exponential function. Go to your textbook, you see the same thing there, but this is the actual proof for why if y is equals to ex, dy over dx will give us the same answer. This is the actual proof. Having known this now, in the next video I'm going to be showing you some questions that relates to this to help your understanding on how this really works. See you in the next video, guys. Thank you.